I think a friend has shared that today's YouTube stream, right? This will be your today's YouTube. Yeah, same thing only. Okay, I'll update this after completion of this particular YouTube. This link in the portal itself. Well, what's the wrong at that? Is the portal YouTube link is not there? What is the meaning of? Is it? It's not visible or it's not updated? Sonu Bharat.
Sir, it redirects to a PDF link, sir. There is no YouTube link available.
Oh, okay. I'm sorry. Oh, it's supplementary content. They didn't show. Okay, I will update this one immediately. Okay, I'll just check with that operational team. Okay, but other than that, I will tell you one thing that YouTube link will be. I'll just share you that main sheet to you so that you can able to access this. I mean, just remind me if possible by end of this session we can discuss. I mean, I can share that link to you all.
Okay, sir.
Okay. Okay, fine. I hope you have watched the week 4 content. Am I right? So, any question from week 4 content? Any doubt from week 4 content?
Sir, yes, sir. Like, how do we express XOR gate in terms of complements and AND gates and OR gates without using SOP or POS?
If I understood your question correctly, you want to implement XOR gate without using
SOP,
SOP and
yeah,
PU,
yeah, yeah.
and you want to implement in universal gate.
Mm, I don't know about universal gate, but using something simpler like OR gates and AND gates.
But anyhow, if you talk about AND gate and OR gate, it is come in the form of it is SOP or POS, right? If I said AND gate, then it is a product terms. If I use OR gate, it is a sum terms. And if I add all the sum terms, then when all the sum, if I product all the sum terms, it is a product of sum. See, you are
Oh,
telling like
okay, okay, okay. Yes,
you
yeah, yeah,
say a
yeah,
b
that's
bar
right.
plus b bar a is an expression, and if I execute this one, it is a one product term and another product term, and all the product terms like this. Really here we have only two product term. If I all the product terms are summed here, it is a sum of product, sum of all the products.
Yes, sir.
Okay, so it is basically we can done by this way. AB and use AB bar. I think I was wrong. This one is right expression. And then A bar and B. And finally, we're going to connect with OR gate. Is it fine? Or reverse operation if I did so, we get the same basis only.
Yes, sir. And how, sir, can we how can we decide that this is the simplest form?
Um, okay. Well,
Like, this cannot be simplified further. This fact, how can we get to that fact?
okay. So you are talking, you are asking me what is the limiting factor to decide this is a simplified expression.
Yes, yes, yes.
Okay. Perhaps I can. We have to choose some other expression so that we can decide it.
Okay, sir. Okay, no
Because
problem.
this is already simplified expression.
Yes.
Okay, then I can't able to say this is a whether I can able to talk this is a simplified or not. Maybe we can tell some min terms so that we can simplify it. Can you spell some min terms? We can try that way.
Mm. I have to think.
Yeah, you just tell some min number. Just min one, m1, m2, like that. I'm asking.
In the forms of M, I don't know, but I can give terms like
Okay.
A B bar plus A bar B, like that.
Okay. What is a b bar? So you just tell me that way. I'll just let me come that way also. Okay, you just tell me.
A B C plus A bar B C plus A bar B bar C bar.
Okay, and I hope all the product term here having 3 literals only, and there is no extra literals. So I can tell this particular function is a dependent variable of a, b, and c.
Yes.
Okay, and if I talk about in the a, as if I consider a as my most significant bit, because I mentioned that is at the leftmost corner and the c at the rightmost corner, so it must be the least significant bit, and middle is the b term. In such a way, if I coin it, this is equal to abc, which is 111 plus 011 plus 000. Can I call like this? It's a function of a comma b comma c, because a is 1, b is 1, c is 1. This product will produce 1. A is, if a is 0 and b is 1 and c is 1, this particular product alone can produce 1. And if a is 0 and b is 0 and c is 0, only this product term can produce output 1.
Yes, sir.
Okay, so this is equal to what, m7 or m3 or m0.
Okay.
Okay, so if you think about in that simplified format, um, well, these two, okay, of course this is your given expression is in very simplified format only, because here when I compare 111 is compared with 011 and 000, then 011 should be compared with 111 and 000. That is, I am comparing these two things. And similarly 000 is compared with 111 and 011. Let me compare this way.
Okay.
So in this case, this particular thing is having how many bit variation?
1 bit.
1 bit variation, and this is
All
3
bits.
bit is varying. Here
1 bit.
again the same expression, which is duplication, so no need to worry about it. This is
3 bits.
not 3 bit.
2 bits. Yes.
This is 2 bit variation. This is 3 bit variation, and this is 2 bit variation. So we got only 1 bit variation is only within these two terms.
Yes, sir.
Okay, so I can tell that maybe I can write down here a, b, c or a, b bars or a bar, b, c or a bar, b bar, c. In this expression, I can take these two things in minimized format like bc of a plus a bar. Is it okay?
Yes, sir.
Plus a bar, bc bar, and that gives bc plus a bar, b bar, c bar. So this is the simplify. I think there will be no more subdivision I can able to simplify here, because I can't find any common terms here.
So the limiting factor is the common term.
Yeah, is in the previous case I consider these two elements, these two product term having common term. So
Yes.
as I said, I one out of 3 literals I can bring it to 2 literals by simplifying. Okay.
Okay.
Then I'm just compare these two also. While comparing these two, there is no relation at all. All are multi-bit varying, so there is no simplification between these two min term. If it
Okay.
is
Okay.
there, what I supposed to do is, for example, assume that maybe instead of this case, let me take another example. Okay, let me take another example, abc plus a bar bc as usual, and instead of this term I'm taking abc bar. Okay,
Yes, sir.
so in this case I already told you this can able to simplify to bc, just now we are discussed.
Yes.
And similarly, if I compare with these two things, is there any common term?
AB.
AB are common. So what I supposed to do is, let me duplicate one more element like this as ABC, which is, what is ABC plus ABC?
ABC.
ABC only. So I can write within these two terms, I can bring AB.
Yes.
Okay. So out of 3 literals, I bring to 2 literals. You may ask, what can I put like P of B dot of A C plus A or something. Can I further reduce like this?
Yes,
But
sir.
there
Yes,
is no
sir.
reduction, right?
Yes.
It is still both are same only. There is no reduction. So I can't say this one. And moreover, this is what type of representation? It is a product of sum. But above one is a sum of product. So basically, I told you we can fix with sum of product than product of sum.
But sir, in the POS, we have lesser number of gates used.
Yeah, maybe. Yeah, in this example, number of
So
gates.
isn't that more simpler form than the previous BC
Yeah,
plus
of
AB?
course. Yes, exactly. So if I asked minimum number of and, I'm just telling you, I'm giving this expression to you. Okay, let's say this is the expression I'm asking, given to you, and I told you you can use n number of two input AND gate, n number of two input OR gate. Maybe I can represent like this. This is refers to two input AND gate, two input OR gate. Just for our notification purpose, please consider this way. If I put two here, means it's a two input AND gate, but it's not a universal notation. I'm just telling you. Or else if I have and three, means the three input AND gate. Okay,
So
but
this and three and or two, this type of three input like gate, and then after that there is input, number of input. So how this notation is used in the industry?
basically this is the note we have to describe such a document. In the documentation we have described like and two, which refers to two input AND gate.
Okay,
Then
so
on the
they
document,
mention the number of inputs in the data sheet, right?
exactly.
Okay.
So that notation should be described in the document. Otherwise, if I tell like this to I'm just making all the circuit design, and finally if without giving documentation to you, it is quite complication for the others to understand the particular document. I mean, I understand the circuit, because they thought like and two is of something, two types, two numbers of AND gate, and they will ask you whether what type of how many inputs of AND gate they are used. That is a big question about it. So if
Yes,
I give the
sir.
documentation clearly, and space two or and two, if it refers to two input AND gate, then it is quite easy to understand between all the team members, peer members.
Yes, sir. Got it.
That is other side. Okay, fine. Let us, for our understanding purpose, I'm just given these two things, and you can choose a number of NOT gate. And NOT gate is just a one input. Okay, and if for confusion purpose, I'll give another thing like NAND 2, NOR 2. Okay, n number of thing you can choose it up. Yeah, I told you just choose n number. Okay, so
Basically, POS and SOP are the same thing, na?
exactly, POS and SOP are same thing only.
Yes, sir.
ABC,
Then
which is
how?
equal to, yes, how?
No, so
So what is your question? I mean, both are same only. The way of
But
expressing only different.
sir,
yes, sir, yes,
but
sir.
POS and SFP are complements of each other.
Yes, sir. If
Can you,
both these equation are different, sir, that's why the POS and SOP are different here.
I didn't understand. Can you
Sir,
please?
in the
He
previous,
is asking what differentiate POS to SOP.
no. I am saying, sir, that the above equation you wrote in black and the down equation you wrote in blue, both are the different.
Yeah, both are
That's why
different.
the number of, yes, sir,
This
that's
is
why the number of gate used in POS SOP is different from number of gate used in POS.
okay. Fine. This is separate case. Okay, please. This is problem one. Let us consider. Okay, this
Yes,
is a problem two. Why I told it, because I want to tell that I introduced the same duplication here. For that case, I changed this term to this way. For
yes,
our understanding only, this is second problem. Please consider this is a second problem, and from this second problem only we got SOP format and POS format. Okay,
yes,
any
yes.
question? Yeah, so in this basis, and we already know that this is again equal to what? B dot of C plus A. Both are same only, because this is expressed in SOP format, this is expressed in POS format. Okay, there's no difference at all. Both are functioning same thing only. Okay, if I think this way of representation, I suppose to put BC and AB should be ANDed, and the resultant of two things should be ORed to bring this up. Whereas here AC should be R and B is to be connected here. That gives answer. Is it fine? Both are same thing only. Number of gates only varied. That's it.
Sir, in the case of problem 1, can we say that like this simplified format, which is BC plus A bar, B bar, C bar. So can we say that for that particular circuit, which has 3 inputs A, B, and C, the output will be 1 when we have B, C as 1 and A, B, C as 0.
Of course, that's a okay. You are taking. You are okay. Well, I'll okay. Here there is no confusion, right? Is it okay, right?
Yes.
Okay, and let me complete this, and I'll talk this one.
Okay.
Okay, here I require 2 number of AND gates and 1 number of OR gate. Here I require AND gate 1, OR gate 1. Comparatively, in this example, PO is really limited number. Okay, and which simplification is best? If you ask, means with respect to the number of components, this is best. Is it okay?
Yes, sir.
But if I tell you another aspect, well, in this example there is no assurer. Already this is proven. Okay, let us try with this example, and then we can discuss in that also. So let us go back to the same black problem, the problem which I defined first. That is the function equal to ABC plus A bar BC plus A bar B bar C bar, and we count that is equal to BC plus A bar B bar C bar. Okay, and this is equal to that of above expression, which is simplified form, and in the form representation in the expression of SOP format. Okay, and what is the question you asked? In the first case, the unsimplified, that is in the canonical representation, if I give A equal to B equal to C equal to 1 and 1, or if I give 0 1 1, or if I give 0 0 0, at any 3 cases, any 1 cases, I supposed to get F equal to 1. Yes, Rituraj Kumar.
Sir, in previous question, you write the SOP format in that blue one, sir.
Yes.
ABC plus A bar BC plus ABC bar plus ABC.
Yeah.
This one, sir.
This
You
one.
write SOP format, and you came to BC plus A plus B. That is also a SOP format. Then after simplifying, it's how you told that this is a POS format B dot C plus A, because we write the equation for SOP format. Then how we get POS format, sir?
From SOP, how you want to bring it to POS? This is a way this is your doubt. Am I right?
Yes, sir. How we can say this is a POS format, because we write the equation in SOP format, sir.
This is law.
Sir, I know that's how you did take a common, but we write that equation in SOP format, na sir, because all the product term are a function of where the function are one, then we write the SOP format. Then how you told that this is a POS format after simplifying it, sir? We can simply say by seeing it's either entries in product or sum.
Both are the same thing, just the representation is different.
I didn't understand the actual question. What is your point? Is it I applied distributed law here from the SOP format? I'm applying distributed law. I can bring SOP to POS. What's the question here?
Sir, my question is, sir, the main equation we write down, it is a for SOP.
Yeah.
Yes.
Okay.
Then how after simplifying that equation we will go to get SOP, na sir? Then
that's why I told you this is a format finalized answer of SOP. Okay, even if you want to write, okay, fine. Maybe I'll ask you other same question for understanding purpose. So this is a SOP format. Can you write the same SOP format to POS?
Yes, sir. Then we have to write in
max terms
plus format.
Yes, in the max term format. Well, and simplify that max term, you will surely get this final most expression. Okay.
Sir, do it now, sir. Please do it.
Okay, but one second. One guy is already asked to execute this part. I'll complete this part and come to that. Is it okay, right? You were asking, your question is, this is given expression is SOP, and how you written POS.
Yes, sir. My
Okay,
yes,
yeah,
sir.
exactly. See, first of all, SOP and POS are same. The way of representation is only different. In the SOP, in the level 1, we all talk with AND arrays. So like here, all things are AND gates. At the level 2, we can have the output of AND gates of things will be connected to the next level, which is OR gates. That is SOP. In the POS, I'll keep all the level 1 with OR gate, and the output of level 1, which is OR output, is connected to the AND input. This is level 2. Okay.
Okay, sir. Then
And
any
both are
question
same.
we can see in a
Yes.
in a form of product, and some then we can say that is a POS format. Either
We can
whether
convert to
it's many,
POS. You can convert that to POS format. See this above
whether that
expression,
equals.
okay, this above expression, I can write in 3 different way. One way is I can write directly. I can write the POS expression. That is, with equivalent of this, I can write the product of some terms. Or by using distributed law, one by one, I can expand it and compare, simplify it. I get this final most expression. Both way is able to do it. So if I'm giving this expression, can you bring it to the POS format? Yes, it is possible. That's my question. That's the only objective I'm talking about.
Okay, sir.
I can
Okay, sir. Got it
explain.
now.
I will just try to give this answer. Okay, but by this taking SOP, okay, and this is a simplified form, and from the simplified form, I'm convert to POS. Instead of this direct way, I'm just try to give the same answer in different approach, which is very long method. Like I take the POS format first,
Yes,
then
sir.
I can write it that way. Also, we can try to prove this both are same.
Yes, I got it now. My
Yeah.
main concern was if the equation is a form of POS SOP, then after simplifying it, we will also get in SOP. Now I
Yes,
got it. Now I got it.
this is also SOP only we are getting. Okay, if you further simplify, that is here there is a dot times of you are getting. So it means
Yes, sir.
the first thing is some R term. It means this is also what can I call this one
B
is
plus
another dot.
0.
Okay, B plus
Yes,
0.
sir. Yes, sir.
Again, some of is product of some like this I'm getting.
Okay, sir. Got it.
Yeah.
Thank you.
Okay.
Sir, SOP and POS are complement of each other. Is it true or not?
No, not at all. If you take min term and max term, that are complement to each other. But connection of all,
Okay.
connection, group set of all the max term, which is exactly equal to the corresponding min term. That's why I told you. Let's take the same example. This is summation of M7, M4, and M0. This is equal to product of M1, M2, M3, M5, M6. These are both are equal. When you talk about what is M naught, that is equal, not equal, that is equal to M naught bar. When I talk about M1, capital M1, that is equal to M small m1 the whole bar. Likewise, capital Mi, which is equal to Mi the whole bar. Is it fine?
Okay. Got it.
Yeah.
Oh, sir, I have a doubt related regarding to week 3 graded assignment. I asked a previous GMeet, but you cannot. You did not change any. Did not change any in the questions.
One second.
In the first question of week 3 graded assignment,
Is
there
deadline is
are
over or deadline is still there?
no, sir.
Deadline
Date
is
is
5,
not
sir.
over.
Deadline is 5.
Okay.
I asked you in the previous Google Meet. You said like that we will change, we will update, but there is no update in the question. So basically, I ask, but there are two or I think 3 questions which are multiple correct question, and you put it on a single correct question.
One second.
Yeah, sir. I
Uh,
also came with the 2. That is
question,
multi-correct, but
question first, sixth, and seventh.
Give me 1 minute. I'll just look at it, the solution, and I'll tell you, because here right now I can able to just check it in this sign, or else
Yes.
let me do another way. Give me 1 minute. I'll just check it out. I hope my screen is not visible, right? Let me check.
Yes, sir. Yes, sir. Screen note is visible.
Okay. 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 I'll just update this. Okay, I'll update and announce to you today itself. And likewise, what are the other questions?
What, sir?
Likewise, what are the other question you had discussed about? Question 1.
Question 1, 6 and 7.
Okay, let me note down it and I'll update now itself today itself.
Yes, sir. Update as
Question number
soon
2 also, sir.
as. What?
Okay, let me check again question number 1 and 2 also and update it.
I think question number 2 is fine.
Okay, that's not a big issue, but let me check. After checking only, I'll just do it. So no issue at all.
Okay, sir. But update as soon as possible because day 5th of Feb is the last date for the submission.
Yes, sure. I'll just update today itself.
Okay.
Okay, I just want to ask you one simple question. What if suppose I have a term and with a dot b the whole bar of whole bar?
Sir, your screen is not visible.
Oh, I'm sorry. I'll just expand it. Sure, just have 1 second. Yeah, is it visible? Yeah. So can you give me this answer for this?
A bar plus A dot B whole bar यानी A dot B simple A dot B without bar, sir. Yes.
This is equal to a bar plus ab. Is it simplified or any other simplification method we can have?
We can use distributive law over there.
Okay, so what is the answer?
A bar plus A dot with
A dot a bar plus a bar dot b. Am I right?
yes, sir.
That plus should come here. Is it okay?
No, sir. A bar plus A dot with A bar plus B. I think so.
Yes, sir.
You mean
Plus
that A bar
B
plus A times of
dot. Yes,
A
sir.
bar plus B. Is it so?
Yes,
Yes,
sir.
sir.
Now you are right.
If it's so, you should get the answer. If I expand it, okay, let's do this particular thing. It is equal to A bar plus A bar B. This one does doing, and this gives 0 plus AB. Am I right?
So then A bar plus A is a simple 1.
Then I will get
Then
A bar
A
plus
bar plus B
AB.
is A bar
Yeah.
plus B is the simplest template.
Sorry.
A bar plus A gives 1, sir.
Yeah, A bar plus A gives 1. Then A bar plus B is the answer you're getting.
Yes, sir. Simplest. Yes, sir.
So the simplified expression is A bar plus B is a simplified expression.
Yes, sir.
Okay. And can I write this in equal to A dot B bar the whole bar?
Yes, sir.
Yes, sir.
Okay. Well, then I can suppose to ask. I mean, last time we had discussed this part. That's why I'm asking so. And if something I have x bar plus y bar the whole bar can be written x dot times.
X plus Y, sir.
It is x plus y.
Yes.
Well, likewise with this notation correlating and this correlation, let me add one more thing. Instead of this expression, I can rewrite. I'm asking like, what is this answer?
B bar plus AB.
B bar plus AB, or this is equal to B bar
A
plus
bar.
A.
Yes, sir. B bar plus.
This is equal to B dot A bar the whole bar. Is it okay?
Yes, sir.
Okay. Okay. Now third one. Now if I pass this A bar the whole bar from the first one and with B dot A bar the whole bar second one and operation, over that I'm putting one more bar, that is x bar dot y bar the whole bar. That gives what? Like with respect to, sorry, this is third one, right? Yeah, compare with second, it just look like second expression, right? Am I right?
Yes, sir.
That give A dot B bar plus B dot A bar.
Super. So this is XOR
XOR
gate.
gate.
XOR gate.
Yes.
So if you do the same process, I'm taking A here and B here and producing first output as A dot B the whole bar. Okay,
Yes, sir.
which I did so. Next, what is that? A dot B the whole bar is given input to A term of an AND gate. I mean, A is one of the input and A B the whole bar is output of the A B the whole bar is another input to the NAND gate. Okay, so A input directly I'm taking and this output I'm taking directly.
Sir, you implement AND gate instead
Yeah,
of NAND.
sorry. Yeah, exactly. NAND gate. Is it okay?
Yes, sir.
Yes, sir.
This gives what? A
A
dot
dot.
B bar the whole bar.
Yes, sir.
If I take the B term and AND it, it gives A bar dot B the whole bar. Am I right? Is it fine? And passing these two things to another NAND gate, that we know that it is A XOR B. Just now we have discussed.
Yes,
So totally 4 NAND gate, 2 input NAND gate is sufficient to implement this XOR operation. And how about XOR operation for to the A XOR B?
one inverter B add if we
Just
want.
exactly one more time. That's it. Okay. Well, with this, under I'm just one since I talk about XOR, I want to. I just told you that A XOR B is equal to A XOR B the whole bar. Is it true, right? Always.
Yes, sir.
Well, I just want to add on some more point. A XOR B XOR C. Since we know about the De Morgan's law and distributed, I mean all the Boolean laws. I'm just asking, what about this thing? Whether it is complemented term or uncomplemented term. I'll just tell you that. Please show that this is equal.
No, sir. It's not true.
Exactly. These are equal. Am I right?
Yes, sir.
Okay. How many of them is it okay or it acceptable? Because previous example I talked with inverted, but now it is not inverted. Is it understandable? Or have you tried this one in the homework? As I've told you the last class, I think so. The live session also, these are equal. You want the proof of it?
Yes, sir.
Okay. So let's take first left side. So A XOR of, can it write like this using what law?
Yes, sir.
Associative law, right?
Yes, sir.
That is equal to A XOR of B XOR C is equal to B C bar plus B bar C. Is it okay?
Sir, AX not B, not. Oh, sir. Oh, okay, okay.
I'm just taking left hand side. Now I will
Yes, sir.
try to bring with the right hand side. I want to
Yes, sir.
prove that one, right? Then this can be, let me label as A XOR of X, where X is equal to B C bar plus A B bar C. That is equal to A X bar plus A bar X. Is it right?
Yes, sir.
Okay, then I can write as A times of X bar is nothing but BC bar plus B bar C plus A bar times of BC bar plus B bar C. I'm sorry, I forgot to put bar here. Okay,
Yes, sir.
and then this is equal to A times of, this is complementary term, this is equal to BC plus B bar C bar. Is it right? Because it is XOR.
Ah, yes, sir. Yes, sir.
Okay, plus the remaining thing as it is. This can be rewritten as ABC plus AB bar C bar plus A bar B C bar plus A bar B C bar. Is it okay?
Yes, sir.
Okay.
It's a simple question.
Now in this exam, I'm just taking C as common. If I take C as common, I can write AB plus A bar B bar. Am I right?
Yes, sir.
Plus C bar common, I can write AB bar plus A bar B. Am I right?
Yes, sir.
This can be written as C times of A XOR B plus C bar times of A XOR B. Am I right?
Yes, sir.
That is equal to C times of A XOR B plus C bar times of A XOR B the whole bar. Am I right?
Yes, sir. Yes, sir.
And let us consider this is X or something like this. This is equal
Yes.
to C XOR X. That is
Yes,
equal to C XOR A XOR B,
B.
which is equal to A XOR B XOR C. Because as per commutative law, I can write like this way also.
Yes.
This is applicable only for Boolean laws only. For two odd number of cases, sometimes this may happen. So we should not directly tell this is equal or not equal. You cannot say that XOR is exactly a complement to each other. Whereas if I given in the form of like this, A, B, C, it is equal to what? Okay, I'll ask this way. Let's say this is F, this is G. What is F equal, G equal to?
A X not B XOR.
Okay, whether G is equal to F.
Yes, sir. It's a it's a X nor with three inputs, so it's equal.
G
No,
equal to F bar, sir.
exactly. G is equal to F bar because I described in the form of gate level. This gate
Oh,
and this
okay.
gate are same, and finally I put inverter. It means G is complemented. But if I tell in the Boolean expression says that they are equal.
Okay, okay, okay.
So that is a confusion rises in every time. So please be careful of recording that cases.
Sure, sure.
Yeah. And so finally point is that you should be very aware of the law so that you can able to implement easily, otherwise it will be complication. So here I applied it with associative law, started with associative law, then I'm expanded and taking common terms using same distributive law, then I'm assigning some variable and again rearranging it with the help of commutative law. It says like this. Okay, so
Okay.
please familiar with the text. Okay. Yes, I forgot to. I asked somebody asked some question. I forgot to continue it. What is the question? Uh, Here in the somebody is asked. What is the
Slides,
question?
in upper slides.
Sorry,
In upper slide, they asked question in on the upper slides.
this
Yes, sir,
one.
that black one, sir. BC plus A bar, B bar, C bar.
Okay. What is the question? Can anyone please recall again me? What is supposed to show here? Maybe you want me to explicitly write that expression in POS. Okay, I think I'm assuming that way. I'll then proceed it. So your function equal to BC plus A bar B bar C bar. If this is a SOP format. If we want to write in POS, let us consider BC plus X, which is equal to B plus X times of C plus X. Is it okay? Where X is equal to B plus A bar B bar C bar, C plus A bar B bar C bar. This is equal to B plus A bar. B plus B bar is 1, then B plus C bar, then C plus A bar, C plus B bar, then C plus C bar. Is it okay? This is a simplified POS format. Is it okay? Yeah, let's try to prove the same thing with the help of original equation. Original equation is ABC plus A bar BC plus AB bar C bar. So I want to bring with this case. So I can write the same thing with a POS format. How can you write simply? It is M7. So I can write this with this case. Am I right? Because this is a POS min term, product sum terms. Right? So M1 can be written as A plus B plus C bar. Am I right? Then M2 can be A plus B bar plus C. Then M3, I think I can copy this particular part because that's what we want to showcase. I can write it in a separate page. So the above expression only I want to prove it up. Sorry, I forgot to write. What are the terms? 1, 2, 3, 5, 6. So 1, 2 is written. 3 can be written as 3, 5, and 6. Is it right? Is it right? This is what M1, right? 0, 0, 1. Because some program will be complemented by SS only. I can write as 0, 0, 1 as A plus B plus C bar. And this is 0, 1, 0 basis in the max term. So it is 0, 1, 0 means it's a M2, capital M2. Then 0, 1, 1 is M3, capital M3. 0, 1, 0. Sorry, 1, 0, 1 it is M5 and 1, 1, 0 is M6. As like this. Am I right? Yeah. So can you take common term means I can consider these two things. If I take these two things common term, a plus c bar is a common, right? Plus b bar. Am I right? This when I expanded these two things, I can write like a plus b plus c bar times of a plus b bar plus c bar. Two expression. Okay. And any other common term? Yeah, I think
B bar and C common we can take from
this from here, right? From v bar.
B bar and C, B bar plus C taking common from second term and fifth term.
This one.
Yes, sir.
Okay, so taking b bar comes c, that plus a bar. So again that will be reduced. Then
Yes, sir.
from these two terms, I can bring b plus c common, right? B plus c bar, right? Okay, what's wrong with it? Again,
Sir,
this
you
is,
can take in.
yeah.
You
Anyhow,
take
it
common,
is.
sir.
Anyhow, I'm getting the same expression. B plus c bar. Oh, okay. Sorry, it's b plus c bar, right? So b plus c bar plus a bar from these two terms. Am I right?
Sir, you used the first term, sir, before in simplifying
That's yeah,
it.
no problem. That's why I told you. What I telling you that this I'm including one more product term. Is it okay? A dot
Okay,
A
sir.
is
Okay,
A
sir.
only, right? Like this.
Oh, yes, sir.
In that way, I'm just talking about. No, there is no issue or duplication, no issue at all. Then any other term I can take common. This is equal to, so far I got only three elements. A plus c bar is there. This I can write as a plus c bar, which is there here. Then b bar plus c. B bar plus c is there. B plus c bar. B plus b bar plus c and b plus c bar is there. Okay. Then a bar plus b. A bar plus b.
A bar plus B we can take common from second term and fourth term.
Fourth term, okay. Second term is a b bar c, right? Am I right or wrong? I
Oh,
think
no,
I was
okay.
wrong. I think so, right? So, right? Because this is I told for two, right? Yeah, two is right. 101. I'm just bring it out with this way. What are the main max term? 1, 2, 3, 5, 7. 1, 2, 3, 5. Sorry. 1, 2, 3, 5, and 7. Yeah. I think there is a redundancy. That's why we cutting like this. This is, if I group these two things, I can get a plus c bar. If I group these two things, I get a plus b bar. A plus b bar is the common term. So a plus b bar is 3 and 4. What is 3? This is 3. Sorry, 3 and 2. Okay, I think this is the term I wanted to group it up. If I group these two things, I get a plus b bar. Am I right?
Yes, sir.
Let me check above. Is there a mistake only I written? I was little confused. Maybe I can write down clearly. So what are the max terms? M1, M2,
M3, M5, M6.
M3, M5, and M6. So M0 is 0, 0, 1. Dot times of M2 is 0, 1, 0, 0, 1, 0. Dot times of 0, 1, 1. Dot times of 1.
Sir, M5 is 1, 0, 1.
Yeah.
A bar B plus C.
A bar B plus C bar, right?
Yes, sir.
101. So 101 means A bar
Yes.
B C bar. Should be
Yes,
put
sir.
R. Then here also I mentioned like there only. 6 means A bar plus B bar plus C. Okay, so if I group these two things, 1 and 3, if I group 1 and 3, I will get, if I group 1 and 3, I will get A plus C bar.
Yes, sir.
A plus C bar plus B bar. And if I group 3 and 2, if I group these two things, I get
A plus B bar.
A plus B bar plus C bar. Then if I group 1 and 5, I group 1 and 5, I will get B plus C
A,
bar plus A
yes,
bar.
B plus.
Then if I group 3 and 4, 3 and 6, I can write B bar plus C bar plus A bar. So that is finally these are cancelled. You'll get the simplified expression of A plus C bar, A plus B bar, B plus C bar, then B bar plus C bar. This is a simplified POS format. Am I wrong? Yeah, this term only getting wrong. Am I right? I'll just clarify the processing process. Otherwise, you'll get a right answer only. Else I can. Yes, I think the mistake is here, right? B bar, C bar. Okay. Okay, I'll just give me one more moment. Let's write down that M0, M4, and M7 shortcut method. Let me write it out. It is A bar, B bar, C bar plus A, B bar, C bar plus ABC. This is the expression we have taken from the initially. Right? Yeah. 3 is the term. This is a mistake. Do you understand? Mistake where it is. Min term 3 is taken in this case, but I thought it is M4. What is M4 will be? Small M4 will be like this only, right?
Yes, sir.
So this expression is not a right expression. Maybe we should think about it. What will be the expression? If I take it this way, when you simplify it, you can write ABC plus B bar C bar. Am I right?
Yes, sir.
So if I expand these things, what is the product term we may get? A plus A bar, A plus B bar, A plus C bar, then B plus B bar is 1, B plus C bar, then C plus B bar plus C, and C plus C bar is 1. So I think we are obtaining the same answer, right? A plus B bar is there here. So A plus B bar. Is it okay, right? This one is okay, right? Can you able to figure out what is the mistake I had done in this case?
Yes, sir.
Yeah. So can you check it up? So A plus B bar. A plus B bar. What is the expression we got? A plus B bar. Then A plus C bar is the next term. So A plus C bar is the next term. B plus C bar is the next term. B plus C bar is the next term. And final most term is B plus C bar. Sorry, B bar plus C. Again, where is a mistake? It should not happen. Yes, I was wrong. This is a 0. This is 1, 1, 1. So I supposed to check. I was wrong for this case. I'm sorry. Maybe we can group these two things only and think there is a mistake called B bar plus C. It should be B bar plus C. It is 2 and 3. This is 2 and 6. If we group it up, we get B bar plus C. I'm sorry. So we're getting answer, but I was stuck it up. Okay, are you? If you have, any doubt in this regard, because in you're getting the answer, no issue at all. But I was mistakenly taken wrongly. This B plus C bar. Because initially I took in these two things, I tried to group it up. Is it possible to group it up?
No, sir.
Because A term is varying, C term is also varying, so it is not possible. But here only two terms are varying, while taking the one term is alone varying, so it is B plus C bar, and we got the same answer here also, B bar plus C. Okay, please check yourself. You just try it yourself. So conclusion is that SOP is equal to POS. That's a kind. Okay. Is it fine? I'm sorry I was taking too much of time. Anyhow, thanks for patient hearing. If any question you can ask now. Otherwise, we can discuss in the next session also.
Sir, I have one doubt, sir,
Yeah.
regarding min term and max term name.
Yeah.
Sir,
please.
in min term, we are taking the function where the output is 1.
Of course.
Yes, sir. Then why it is min term, sir? It should be max term. And in max term, we are taking the function where the output is 0.
Okay. So what is your question?
So it's naming min term and max term. It should be opposite thing. Why it should be min term, sir? Because the output is 1. That is maximum.
Oh, why they named as a min term and max term? Okay, the min term in the sense that is product terms. They are defined as a product terms. Okay, and we are not complementing anything while doing so. And you are asking why they name it as a min term. Is it so?
Yes, a min term means something should be minimum. Like
Not
it
like
sounds
that.
like
Not like
and
that. But your analogy is okay, acceptable, but it is not so. Actually, min term in the sense it is a product terms.
okay, sir.
Max term is sum terms. That's the meaning of it. That's it. There is no min means minimum value, max means maximum value. If you want to know about what they call so, I'll just verify and check you and tell you back in next class. But it's totally different from that. Anyhow, any other question? Well, shall we wind up?
Sir, I have a question.
Yeah, please.
Without writing the Boolean expression for M0, M1 like min terms or max terms, can we simplify?
Karnaugh map.
Not regarding Karnaugh map. Okay. So the solution is Karnaugh map.
Yeah.
Okay.
That's here. I've just look here. I'm just used K map here. But maybe in the next week we know about this method. But why I choose on this method is it is quite hard for me to which bit particular max terms are having less, 1 bit variation. So if I map with this k map, using the k map, I can able to just identify this. I can tell that these two are adjacent and these two are adjacent. Like this, I can able to identify it very easily. So Karnapap is helpful for you.
Okay. Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you all. Thank you
Thank
all
you,
for
sir.
patient hearing, and I will just share you that live session links in the portal itself by today itself. By today, I'll just update it.
And sir, one more thing, in the YouTube playlist there are not all the videos, like
Okay, I'll just update that link itself. For live session link, if you get it in the portal itself, then you can get access the link itself. You can have the link of each and every live sessions.
Okay, sir.
And I'll just update that one. Okay, thank you.
Thank you, sir.
Thank you all.